it's working. It happens automatically. Once you start speaking, the camera moves. Oh, it's on. Good morning, everyone. Is the sound okay? Yes. Welcome to SRv6 Ops and welcome to Madrid. So this is the note well. We all, when we participate, when we join any of our IETF venues, registers for the meeting, we agree to this, follow this note well. We have various rules that we follow on how our contribution and participation at IETF is judged based on the internet standard process, the working group process, code of conduct, IPR, privacy policies, and others. You should be aware of it. You have already agreed to it by being in this room. Some of the things we really want to highlight is that we want to run these meetings smoothly. We want to make sure that there is no harassment of any kind, and the meetings are done in a professional setting. So please take care of that during this meeting as well as on the mailing list. There are various tools available at the IETF. So if you are facing any problem, please feel free to reach out to the chairs and ADs, and we are here to help you. Meeting tips, we all are on the Meet Echo already. The main thing that I want to highlight is people in the room, please log into the Meet Echo session as well. It's very important that your attendance is counted, and that's the way that we do it, especially for people who are in the room. Make sure for people who are remote that don't send audio and video directly. Please join the queue, and once you are being recognized, then send audio and video. Administrative, we would have our collaborative minutes in the note tracker. One of the chairs would put the link in the chat as well. Please help if you can, and make sure that all the inputs that you're providing are actually captured well. We will of course go through the recordings and clean it up, but it's good to have something starting to work with rather than a blank page at that time. So thanks for that. The thing would be that we are also doing the chat. So any longer discussion can be done on mailing list and chat, but keep the questions critical to the point when you are asking the presenter. Please use the mailing list more actively. That's something that we can all improve. We have a wiki where we are storing some information from the chair side, but this is a community wiki. So if there is some information worth noting, please come do it. If you have ideas on how to enhance the wiki, please reach out. All of this is linked at the data tracker page as well. We also have our GitHub. If there are things that we want to put on the working group GitHub, the chairs are completely open to ideas from the community as well. Some of the admin stuff. Between the last two meetings, we received a liaison. This liaison from ITUT study group 11 went to bunch of groups in the IETF, and a response was sent to them clarifying on the IETF position on this conformance to SRv6. We clarified a few things on how IETF works. We identified some of the issues that they had in the liaison as well, and directed them to BMWG as the place which is the closest to something in the IETF that deals with conformance and methodology for any of a benchmarking and testing ideas. We receive a response from them, which was mainly for information and mainly an ACK, but somehow this information came only to SRv6OPS. So again, our ADs from the OPS area directed them and responded to them saying that BMWG is the right place that you should be sending this information to. And that's the status with this communication between the ITUT's study group 11 and us. Some admin items. We have a document which was recently discussed at the last meeting as well as on the mailing list. as chairs, we would think that this would be the document that we might issue an adoption call at some point. There are still an update pending from the authors. There are issues which are pending. So hopefully once those issues are resolved, we would be doing an adoption call. So this is more of an information to the community that this document is something that we would target. So if you have comments, sending comments early always help, rather than waiting it only during the adoption time. So especially if you have concerns with the document, please raise them as early as possible. This is again an initiative that the chairs did. We created a working group website. We have put it on our GitHub as well. So this website mainly is directed for people who are not active on the IETF, and sending them our data tracker page. It's sometimes not the most useful thing for them to figure out what was discussed in the past meeting, and being inviting to more operators to come and participate in the IETF. So we prepared a page which was very much directed towards non-IETF folks and but who are operating SRv6 networks, and how we can provide them useful pointers to what are the operator presentations that have happened in past, and we are open to remote participation. So more and more voices that are sort of missing, this forum could be a place for them to come in. The source is maintained on GitHub. So if you have ideas on how to improve this, please reach out, and we would like to work with you on that as well. And that's it. This is the last slide. This is our agenda. In today's agenda, we have a bunch of operator presentations. Again, thanks for coming and talking to the working group on how you are deploying SRv6 in your networks. And it's a good mix of an ISP, an IXP, and a web service folks. So we will hear from various different operators on how things are happening in the SRv6 network as well. We have a white paper which has been recently published by the operators, so they would like to talk about it. So that's our the white paper section, and then the usual the working group drafts presentation that we heard. We have deployment options, 2 new drafts, and 1 draft which is in 6-man, but it's here for information and more for feedback for this community. Is there any agenda bashing, any issues, anything else that people want to discuss in today's meeting? Okay, hearing nothing, let's start with our first presenter, Niels. Okay, take back slide control, then stop slide, share slide. Thank you. Selection.
Okay, good morning, everyone. My name is Niels, and I'm the lead architect for the IP backbone at Deutsche Telekom. What I'm talking to you today about is how we do traffic engineering for our backbone, and what challenges we face on our way to advancing that towards SRv6. This presentation has been prepared mainly by our 2 SMEs, Timmy and Martin, who unfortunately can't be here today, so I'll present on their behalf. So, what is it? We've been doing ISP now pretty much exactly for 30 years, and for about 25 years we have been doing our traffic engineering the way you will see today. So it has been steadily advanced, but always in the same manner. We are always looking at our traffic matrix. So our traffic matrix is basically a map laying out end-to-end inside our core, how the traffic is flowing, where we have how much capacity, and where we have a certain demand. So our network today is, as many of you know, based on LDP and segment routing MPLS. And since about 1 year, we are working towards advancing that for SRv6, mainly for simplification and network programmability. In order to calculate our traffic matrix, we need 2 things. First of all, of course, our inventory, but then we are collecting performance data, mainly MPLS forwarding statistic counters and interface counters. We take all of that, apply our inventory data, and put it into our secret source, our custom-built TE engine, which is in the back end also using a commercial product, but more to that on the next slides. The challenges we see today is that the amount of time we need to create this traffic matrix works pretty okay for our tactical traffic engineering, but it does not fulfill any assurance-related requirements. And especially for the assurance-related requirements, we have seen in the last 10 years a strong push that all of these requirements have increased, and that we are now seeing a demand for visibility on trends in under 10 minutes. Furthermore, our so loved and used MPLS forwarding counters are, of course, no longer valid in SRv6, so we need to find a way how to deal with that. So ideally, we want to find a new approach where we can use and make use of the same method of calculation for LDP MPLS, segment routing MPLS, and SRv6. Okay, so looking towards SRv6, what's our main motivations? DT operates the AS3320, as many of you know, but we are also running a lot of local ASs in our so-called national companies. These national companies oftentimes even have multiple ASs per country, and putting in new products or establishing products across AS borders is rather complex, and sometimes even requiring dedicated workarounds, which are not really the dream for any network architect. So we are really driving this in order to see the opportunity with a step towards SRv6 to clean up and significantly simplify our situation. So, our traffic matrix, the heart of our traffic engineering. What do we do? First of all, we need the inventory data, especially the LSRs, so our P routers from the core. And there, the routers and the links, as well as its attributes, as in bandwidth metrics and delay. After we've gathered these data, we are mapping them to our SRLGs. So basically, really to the fibers in the ground, we know which paths they are running in order to make what-if scenarios in the aftermath of our calculation. Then we collect from the network our performance data, as mentioned before, our MPLS traffic counters and their next hops. This is executed every 15 minutes. We collect our interface statistics every 5 minutes, and we measure the network on the links once per day. So as an example on the map, you can see the outcome is that between Hamburg and Berlin, we have the capacity in this example of 3 times 400 gig. And we have a demand on the bottom from Hamburg to Stuttgart, or Stuttgart to Hamburg, of 4,711 megabits. So that's the difference between inventory data and performance data. Both of that is used in our calculation. So which steps do we do in order to get to the traffic matrix? In order to show a trend, you need 2 collecting instances. So the first collecting instance starts at minute 0, and the second at minute 15. So we often get the questions from other partners or also our internal people, why don't we simply reduce the collection times to 5 or 3 minutes in order to get more granular data? The answer is our largest routers need up to 11 minutes to prepare the data and provide them. So it doesn't make sense to start overlapping collections because the data is corrupted if you use it then. So at minute 30, we can start to compute our traffic matrix. That's a rather quick step. As you can see, it's done in under 1 minute. and to do the what-if simulations for the performance data. Now, this really depends on the granularity, what you want to see, but roughly 5 to 8 minutes is the typical time in order to do that, which means at around about roughly 40 minutes after real time, we are then able to have the first results of our simulations for a trend. That's perfectly okay for planning. That's perfectly okay for estimating what you should do or review what you should do currently if you have any congestion in your network. But that's not okay for the simulation, for assurance reasons. And our ambition is to drive that calculations between below 15 minutes, rather more towards 10 minutes. Right, so I was talking about the secret sauce. So that's our secret sauce. It's a self-developed tool suite, complemented in the backend with a tool of WAE, often changed names and companies, associations, but we've been using that since the start. So after all the data is inserted, we are getting an end-to-end traffic matrix out of that, comprising topology, traffic, and SRLGs. We use that to calculate and deploy our ISIS metrics for the whole network, as well as calculate where we are going to install SRTE tunnels, midpoint optimizations. And we use that also for what-if failure scenarios. Are we going to get into an overload of certain links if we lose one half of our network? Are we going to have circular routing or suboptimal routing if we lose certain links in our network? All of that is simulated here in this box. So summing up to my last slide, our pain points for the ETE requirements towards SRv6 really is we're losing the counter. So what are we going to do? Our current ideas is, and we are currently setting up our lab in order to evaluate these options. First of all, idea number one, re-engineer the traffic matrix based on IPFix data. I would very much like the idea, and you get the aggregated IPFix data as a constant stream, and the precision, as due to the sampling rate, might be a little bit more granular and not as detailed as you would get it with the MPLS traffic counters. However, this might be significantly faster. The idea is, the second idea is to do the traffic matrix based on data collection for the SRv6 local counters. That more or less keeps the idea very similar to what we do today, but we are not quite sure if we are getting to the speed that we're going to wish. So these are the two options. This is going to be validated in our lab, presumably in the next 6 or 7 months. So yeah, that's basically it. So I'm open and happy to take questions.
You have you to say something.
Yes, but that's from.
Okay.
Yeah. Hello, Boris Hasanov. Two short question. Am I correct what currently you are using SNMP for counters collection?
Not really. Correct me, we are using telemetry, Google gRPC for, GNMI, for the data collection.
Okay. And second question, do you or will you consider MSD as criteria for path calculation for SRv6?
What do you understand as SM?
MSD, maximum seed depth.
Oh, that we are looking into, but we haven't made up our minds so far.
Thanks a lot.
Second question. Well, that depends on the address summarization that we are currently looking at. We have a lot of BNGs, around 2,500 at the moment. And our regions, at least nationally, currently reside around the deployment of these BNGs. So that's one option that we're looking into.
Okay, thank you.
Hi, Niels. You mentioned that you are measuring the latency once per day. So with this idea of transitioning to SRv6, would be also a matter of increasing the frequency of the measurement of the latency, or it's just pure capacity what you are intended to do?
So what we've seen is that the latency doesn't vary very much throughout the day on the same link. That's why once per day was so far very, very sufficient. If this changes, we can easily increase it. That's just, you know, easy matter of increasing. But if we go for the IPFix based measurement, we are also looking for the option to use on-pass telemetry there. And on-pass with IPFix would be a feature that we love to have from our vendors any type of the day. So that's a big ask for them to implement it.
Okay, thank you.
Yes.
Oh, okay. Okay, if I'm next. Greg Mirsky, Ericsson. So you consider to do a SRv6 address aggregation. Is that in combination with the packed SIDs? So basically...
Microsits, you mean?
Yeah.
Yes, we are looking to do that as well for the network programmability services. Yeah.
Okay, thank you.
Okay, and before I close, I would like to hand over to Marcus with a collaboration request for the group.
Marcus, we are over time. I try to keep it very short. Marcus Arment, Deutsche Telekom group, responsible for core and services, developing the strategy and architecture for our whole footprint. Why I'm here? We are investigating in the context of 6G to use SRv6 for the mobile user plane, replacing GTPU. And during the hackathon, we found out that it would be good at least to announce this work and make you in this round aware about this activity. And I'm happy to discuss after the session with you in case you are interested. We have here a number of motivations. I do not want to go through all of them. Maybe the first three are the most important ones. So we see limitations with the GTP tunneling. We see that more and more traffic in our network moves towards end-to-end IPv6. And thirdly, Niels pointed it out, we are in the progress to moving towards SRv6 in our transport networks. That are the strong motivations, but let us believe that it makes sense also to have in the mobile user plane SRv6 and to use it natively along with the end-to-end IPv6 transmissions. So in 3GPP, the process now of 6G specification starts with the study phase. This is not the normative phase, it's the study phase where we have time then together to look into topics. And for this study phase, we propose to investigate SRv6 for the mobile user plane. So at the bottom right, you see the timeline, and that's the important thing. We need your support here. With some of you here in this round, we are already in good collaboration, but I think it would be good to have more operators, especially those operators who work on SRv6, to support us in 3GPP, especially if you have delegates in SA2, to cooperate together with us and to work on joint contributions. So that's why I want to invite you to collaborate with us to support or to go together in 3GPP and use the chance of 6G to study this. Otherwise, within the next 10, 15 years, we will not see any SRv6 in the mobile user plane. So the contact data is here. Maria and my team, she is heavily working on that, or you can even reach out to me maybe after the session. Thank you.
Questions. People who are asking questions, please be very quick. Satoru.
Satoru from SoftBank. Thank you very much for sharing your work on 3GPP side. I think I just want to bring in my support for your work. And I think also my colleague on CGPP side engage your colleague.
Yeah.
So I think we can work together. So please let me know what's the next action for us for the next CGPP meeting, and a call for another operator join this project.
Thank you. Thank you, Satoru.
Greg?
Greg Mirsky Erickson. Yes, thank you for this update. Very interesting. Just clarification question. So when you look for applicability of SRv6 in the mobile network, does it include the front haul?
Yes.
And how you address that eCPRI is not defined for IP?
I mean, I think that is now a very, very detailed question where it's probably too early to discuss this now. So that should be exactly part of the study phase.
Okay, thank you.
GPP.
Keyur, very quickly.
Yeah, Keyur Patel Arcus, wonderful work. I'm not part of any service providers. We are a vendor, but we'd love to support you on your ongoing work. Yeah, awesome.
Thank you.
I'll go on the list.
Please take it to the chat on the list. Okay, thank you so much. Fabio, yes, please. I'll give you the slide control.
Okay, can you hear me?
Yes, Fabio, we can hear you.
Okay, great. Okay.
Dhruv, there was a comment that Peter wanted to make from 3GPP, perhaps.
Fabio, just 1 second. I think Peter, go
Okay.
ahead. ADs trump us chairs at any moment.
Yeah, I just want to raise a question because you mentioned you want to study the SRv6 on the user plane. The responsive working group is CT4. Are you also going to go to CT4 and propose it there? Because there will be a study item on the protocol for the user plane.
Yeah. I think at this stage, SI2 is the right one. And if it goes to stage 3, I think then CT groups are the relevant ones. But let's discuss after the session.
Yeah, sorry for that, Fabio. Go ahead.
That's okay. Okay, hi everyone. My name is Fabio. I'm a network engineer at IX.br, and I'm here to talk a little bit about our SRv6 implementation in our Internet Exchange. Okay. Brazil Internet Exchange is a project that started in 2004, and the main goal is to deploy Internet Exchange in metro areas in Brazil. Nowadays, we are running 38 Internet Exchanges that are not interconnected, totally isolated networks, and the total peak of traffic in all these IXPs nowadays is around 42 terabits per second. Okay, São Paulo is the largest IXP in the world. Okay, we have more than 2,500 members using more than 3,000 routers, and we have daily peak of traffic of 27.2 terabits per second. In this Internet Exchange. In São Paulo area, in this Internet Exchange, we are present in 31 data centers using 32PE routers, and we have a lot of member ports for sure. Most of the participant member ports are 100 gig interfaces, and now we are seeing a real increase in the 4 gig connections to members.
Fabio, can you speak a little louder? Maybe keep the mic more close to you so that we can hear you more properly.
Okay. It's better?
Folks,
better now?
Is it better? Yeah, it's better. Thank you.
Okay. So actually, the IXPs, the Internet Exchange, provide layer 2 connections between autonomous systems.
You made it worse somehow. So just come close to your mic.
Okay. It's better now?
Yes.
Okay. So we do this layer 2 networks, provide this kind of service doing overlay networks using CLO-like topology in these metropolitan areas in Brazil. Okay, we use multi-vendor device in these networks, not stuck in a single vendor. And as you can imagine, with this huge amount of traffic in these metro areas, we have a lot of large uplinks between the devices. So sometimes we have uplinks with 13 400 gig interfaces, and we have to make sure that the traffic is properly load balanced in these interface members, in these LACPs, and also in the ECMPs, the equal cost in the network. And for that, usually we always rely on FAT labels and control word to make sure that the traffic is always well balanced in the network. That's a key point for us, right? And we, as most of the networks, we need to provide a good service with fast convergency and keep the operations very simple. So we saw the need to move from VPLS that we were using to EVPN. But why exactly? The main reason here was to use ProxARP and ProxyND in EVPN services. As you can imagine, a layer 2 network with more than 3,000 routers have a lot of ARP, a lot of ND, and it's this high ARP and ND rate can cause problems to our members. So with ProxARP and ND, we can rely on a service to reduce the amount of ARP forward to our members. And also VPN is very easy to maintain, to configure, give me a better scale in my network, more visibility. I can really provide a better service to my members and do the migration from VPLS to VPN very smoothly. Okay. But okay, but why segment routing v6? Why using SRv6 as the data plane? We could also use MPLS in that. But as you know, with VPLS, we have a little bit more complexity. We have a stack of labels and more protocols involved. So as you can see here, we have a label for reach the destination, one for the specific service, and we have to use 2 labels just to provide the load balance in the path, right? When we move to segment routing v6 with complexity, all these instructions to the network are inside the IPv6 header, right? So I just encapsulate my Ethernet traffic inside an IPv6. So my instruction to load balance use the flow label in the header, and I put the instructions for the traffic in the CC'd instructions, right? So actually, SRv6 is very simple to operate. It was a better way to operate the network very easily. And we gain all the benefits that we know from SR, right? Like micro-loop avoidance, fast network conversion, source routing. But for us, the key point was the flow label field in the IPv6 header, right? Using that, we didn't have to wait for any FAT implementation for a VPN. I just rely on something on a field that is there for years, and vendors are already used to that, and it's very simple for them to use that. And also, my core devices don't need to and don't need anything fancy, right? I just have to enable IPv6 and that's it. It's working. It was very easy to start our deployment. We didn't have to replace any core device in the network. So our path to do this migration was, we had these VPLS networks using LDP and OSPF. And in the day zero, we just enable IPv6 and ISIS in the core. No SR at all. My core doesn't know what is SR, just IPv6. And then I started to replace my PE routers in the network one by one. Every time I add a new PE router that already knows EVPN and SRv6, they talk between them using EVPN and SRv6. The traffic between EVPN and to VPLS, to the legacy network, still uses the VPLS, the MPLS, but every time I add a new device using the VPN, the traffic already uses the SR. So that's very good. I don't have any gateway between the two networks, right? So I can really improve the deployment very smoothly. My customers, my members didn't notice that I'm doing this kind of migration, right? So we kept replacing the PE routes until a point that we will have 100% of the device talking EVPN and SRv6. The address schema that we used, we got the locators from the unique local address range. Okay, we got /16 just for the locators for all IXPs, and from that range we used the bit 17 to 32 just to represent each of the regions or IXPs that we managed today. And one of the tools that we use to monitor this evolution to the SR network, we got our uplinks before using just MPLS, so we were already monitoring that, and we started to monitor the IPv6 traffic in the interface as well. So as you can see here in the picture, I can see that part of the total traffic in the interface now is IPv6. So I can see the IPv6 traffic is growing in time, and I can see this deployment improvement. This is the timeline of our implementations. We start the EVPN deployment in a small IXP that IX.br Brazil, but in the start we used MPLS. Okay, we were not in February 2024, and we are not that confident with SR yet. So we took some months to really understand, to really test, to really be confident with that. And in June, we moved from MPLS to SRv6. Then in September, we enabled a new IXP, another IXP, IX.br Curitiba, to SRv6 as well. And in November, we started our journey in the São Paulo network. And we have been doing the improvement in São Paulo network since then. And now in July, we have around 7-8% of our devices already talking between them using the VPN with SRv6, right? So we plan to have almost 100% in September. And the challenge that we faced in this journey was it was a little bit difficult to find the best practice that could help us in this process to make really the decision to move to SRv6. And we always have to train our teams, internal teams, to understand these new technologies. and understand how it works. And every new member in our internal team, we have to train them, because it's very difficult to find in the market someone that really understands how it works, right? And sometimes it's very difficult to find documentations from the vendors. And actually, the support teams in vendors still have some difficulties with the technology as well. They are not used to that yet, right? And one specific problem that we have, we were using a specific chassis model in our network, and we found out that this specific router chassis didn't use the IPv6 flow label field to do the load balance. So we can't use that chassis SP router anymore, right? And also we found some minor bugs with vendors. Okay, that's it. Thank you very much for the opportunity.
We are using Meet Echo to join.
Oh, okay.
So he's joined the queue, or I can open the queue for you.
Go ahead.
But let Tom go first.
All right, no worries. Thanks, Tom Hill from BT. You are a man after my own heart, I think, when it comes to doing technology migrations. I think that's really very impressive that you've done that in live with no customer impact. So well done. Should be commended. I was really curious, actually, though. I mean, you've obviously got a multi-vendor environment. Are you able to reveal some of the hardware you're using? Because I feel like that's actually quite a feat for some of this hardware to do all of those things at once.
Sorry, I didn't get the point of your question. Can you
I'm curious who the vendors that you're actually working with and the hardware types. Are we talking cheap boxes, ASIC boxes? Are we talking big MPU boxes or something like that?
No, usually we use most of the devices are pizza boxes using Jericho chipsets, and some chassis using some specific vendor chipsets. So nothing very fancy.
Yeah, one last little thing, if I may. The CSID RFC has only just been standardized recently as an RFC. Did you have any problems with interim solutions in software? Did you have any issues with upgrades recently, or anything you had to change?
No, actually, to be honest, I'm not using the last version of my version of software of my vendors, and the versions were previous to the official RFC. So, but the interoperability between different vendors is working fine. I didn't find problems so far, but for sure I will take some considerations when I decide to do the next upgrade in my network. Right.
Yeah, cool. Thanks very much for your presentation.
Thank you.
Sami, please be concise in your question.
Yeah, Sami Boutros, Siena. Yeah, I just have one question about the scale you have for the Mac on your EVPN network. I assume you only are learning router Macs, right?
Correct.
Okay, thank you.
Okay. Quick question. You say you're using CSID, which makes good sense. I understand that. Are you using the next flavor, the replace flavor, or both flavors? Because there are two flavors that have been in the draft for many and many years.
To be honest, I'm not sure.
Joel, I can answer that. Like, that initial term was microset, so I would assume that they were using Next.
Okay, I just trying
yeah.
to make sure I understood. Thank you.
Yeah.
I gave them that comment that, like, we prefer using Next season.
Yeah.
Okay, let's move to the next presenter. Thank you so much for coming and presenting, and thanks for.
Thank you, guys.
Thank you.
Thank you. Hello, guys. I'm Boris Hasanov from MTS Web Services, and today we'll deliver a very short presentation about our use case for SRv6 in the cloud. Go ahead. Oops, as usually.
1 second. It should be now.
This is a very short introduction about our company. For those of you who visited yesterday's NMOP VG presentation, I will be just repeating. So we're a subsidiary of MTS, Russian and CIS countries, mobile and wireline SP, and our goal is to create like totally a new vendor-independent greenfield version of public cloud. So focusing on IIS, currently PIS till the end of this year. Very simple network topology from physical point of view, just regular CLO. The only difference is what you are quite small scale, I would say, versus big hyperscalers. We use dual homed server connections. So point of failure is server, not the rack. To the data centers at the moment and availability zones to third is in the progress. So let's quickly go from the bottom to the top. We use Kubernetes pods for infrastructure services. Each pod has unique IPv6 address. We have clear separation. This slide looks very overloaded, I understand, so let me focus on the most important parts. So we have clear separation of interfaces for data plane, for example, 400G, and LOM interface for host management and access to, for example, Kubernetes services. We have pretty funny routing or interesting, I would say. So for these host prefixes and Kubernetes services, we use Cilium BGP agent because we use Cilium CNI for Kubernetes. So we announced it via LOM interface. For data prefixes, we have 2 instances of FRR. But before that, I would like to say what we use SRIOV, and we divide each physical interface or physical function on the host into 2 pieces, 2 virtual functions. One of them is used for infrastructure FRR connection, and it keeps in the kernel space. And with FRR infra, as we call it, used for announcing pod prefixes, load balancing prefixes, etc. Second one is used for VPC, and it goes via VPP, and we use TAP interfaces. And second instance of FRR, we call it FRR VPC, is used for SRv6 locator announcement and some other cloud internal services. So we have finally 2 BGP sessions per each physical port and 1 management BGP session. Here's a very brief picture of underlay IP fabric. So you can see dual homed host. Its architecture is based on pure eBGP, like in RFC 7938 routing on host, as I already mentioned. So just eBGP, IPv6 unicast, end-to-end. Switches are just IPv6 forwarders, so our complexity is on the host. So we directly followed rules from RFC 1925, it's much easier to move complexity or problems on another abstraction level. So we moved it on the hosts. And use of free VPN in overlays. So why we decide to use SRv6 inside data center? So first of all, we used and still use two traditional, I would say, overlay solutions and virtualization solutions. One of them is proprietary from one vendor and like hardware overlay plus software virtualization also from very well-known vendor. We have also another network based on BGP VXLAN, hardware-based overlay, so it starts from switches, and again combined with software overlay from the vendor. Of course, it's understandable that it cannot scale in the long run, and that's why for this new greenfield version of the public cloud, we decided to pick up SRv6. Why? First of all, because as just Fabio mentioned for IXP, it allows us to make pure, clear separation, like just IPv6 underlay, no more like lock-in for any fancy switches, functions, etc., etc. Just IPv6 forwarding, flow label support, telemetry, etc., etc. So some very basic requirements, I would say. Programmability, very flexible programmability on the host. We can incrementally add functions which we need. So far we use and DT only functions, but it can be extended in the future. So, and from my point of view, it's very important what the SRv6 can be used as inside DC, as outside for DCI, up to edge data center, so we can create, as colleagues from Deutsche Telekom showed, like create end-to-end SRv6 path. So we developed everything on the scratch, and we focused on central controller-based architecture. We called our controller, it can be considered as SDN controller or just controller, whatever. Name is CPL. I guess what it's like abbreviation of control plane. Developed on top also Kubernetes cluster. It has, for example, main central instance or entity of controller, which has API gateway for communicating with front end where customer will order VMs. It has separate instances of responsible for management controllers on different availability zones. Also entities responsible for IP address management and different other configuration parameters. We have REST-like API between a central instance of controller and remote instances which are placed in per each DC in each availability zone. And that remote instance communicates with, we call it host network agent or network agent on which is placed, it's also software function which is placed on each host. And this agent communicates with different pieces of like control plane and data plane on the host, like VPP, FRR, etc., Linux kernel, DNS, via different APIs. This is like main idea of this is very simplified procedure how this overlay is created. So initially each host during this automation provisioning phase, we put special configuration file on each host which has a specific host prefix. So host network agent reads this prefix from this config file and sends request for local CPL controller instance. So CPL receives it and replying according to this particular prefix with some also algorithmically assigned entities. We called it network attachment ID. It's just basically some number. It's sort of identity for network for particular host. It sends this network attachment ID towards the host network agent, and host network agent uses this for creation local seed on the host. And also what's very important, controller also sends to network agent VPN prefixes. So we do not use anymore BGP for VPN prefixes distribution. It's also central controlled provision. Network agent creates SR policy and pushes it into VPP. So this is the logic. Here is the extraction from configuration template. It has all these parameters. Example of overlay. So if we will have a look to FIPS for different VPP related to different VPP, we will see what we have VMs where next hops is available via SRv6 next hop. So we have this recursion. The same approach is for going outside, for going to internet. So we use VRF outside and we have to reach it via SRv6. It's very also short illustration to what I said earlier. CPL sends information to agent. Agent creates SR policy. I just wanted to highlight what binding seed is also algorithmically constructed. Based on these parameters, we have endpoint in our VM and one candidate path in SR policy. So SR policy so far very simple. It has one candidate path, one segment list, and one seed in this segment list. So we use for forwarding, we just use like BGP best path, right, to reach this VM. So next step, since we are currently in phase of transition to GA phase, so fixing issues, we have incidents. One of them I described yesterday, so heavy work to be ready for GA. We have some work in progress how to bring high availability for borders connection. We also work on extension of SR policy to use more seeds and more segment lists, and it's additional research. And very important part is how to deliver PM in this customer environment, because we cannot touch customer VM basically, but we need to measure the connectivity, etc., etc. And finally, the final slide, I just recently published an article on LinkedIn about how do we program VPP from network agent, about some details of this BNAPI and SR policy stuff. So that's all. Thanks a lot for hearing. Questions?
Any question for Boris? Thanks for the great presentation. Thanks.
Okay. Thanks.
Next we have Liaison.
Hello, everyone. I'm Yisung Liu from China Mobile, and today I will introduce this white paper on behalf of all the contributors from the China Mobile, Bell Canada, Swisscom, Deutsche Telekom, Alibaba, MTN, and Telefonica. Firstly, why operators need SRv6? Because the SRv6 combined with the SDN can optimize the routing and OPS, and the protocols can be reduced. And the SRv6 will provide the routing service and applications three-level programming, and it can be smoothly migration based on the IPv6. So why does the SRv6 require header compression? And mainly because the SRH overhead problem. So including that the low transmission efficiency and the complex implementation and the high migration cost. And so when if we use the compressed SRv6, we will achieve three benefits. that including efficient carriage and high scalability and smooth evolution. And so at the end of the June this year, and the CC RFC 9800 has standards, and the CC RFC including 2 flavors. All the flavors are defined under SRv6 networking programming architecture, and the mainstream vendors have successfully completed the CC integration testing. So in this white paper, we have discussed the 5 parts of the deployment and scenario and the practice. The first one is the seed assignment, both for the replace seed and the next seed. For the block assignment, we recommend that structure the address space by the AS number in supporting of the inter-domain SRv6 networks, and the boundary device have the simple ACL policy configuration to prevent the seed information leakage. And we also can use the flexible be encoded in the CSID block. And for the CSID itself assignment, we recommend that the consistency between the compressed and uncompressed seed. It may save the space, but may limit the uncompressed seed length. And we can allocate the hierarchical network ID. And also, the JIB and the LIB can share the same seed. And the second part is that the inter-AS. Inter-AS include, for the intra-AS, we may have multiple IGP processes. And the IGP advertise the locator rules and the CC nodes and the CC links and the topology. And for the inter-AS, we have multiple AS BGP. BGP can advertise the aggregated routes between AS, and we use the EPE links and the CC. For the single layer controller mode for the multiple AS, we use the BGP send the information of the CC and the SRv6 policy to deliver the CC list. And we can establish the inter-AS E2E CC with the highest compression efficiency. And the third part is the visualization. We have 3 levels of this visualization. The first one is the physical topology. We can use the LDP and YAM push to report, and we can use the T-Web step for the per-link measurement. And for the CC policy visualization, we can detection the latency, bandwidth, and the packet loss, etc. Via the IOM or IFET. And we can use the telemetry reporting for the real CC policy quality. And for the service visualization, we can use the IOM IFET stem detection for the service level quality. And we can use the YAM push and IPFix to reporting the service layer quality. And the third and the fourth part is the traffic steering. We have 2 main types of this. The first one is based on the destination address, and including the bounding seed based, and also the color based, and the IGP shortcut. And the second type for the traffic characteristics, including the DSCP 802.1q and the traffic class, and also use the BDP flow spec to match the packet field of information, or use the PBR to match the packet information. For the fifth part, that's the traffic protection. We have also 3 levels. The first is the policy level, that we recommend to use the CC for the hot standby, both primary and backup paths. And we can use BFD detection, the bidirectional path consistency. For the local protection, we recommend the TRFA repair list use the CC. And the local BFD detection time should be shorter than the hot standby path BFD. And for the VPN level protection, we recommend to establish the primary and backup CC the policy to both the egress PEs, and we will switch from the primary to the backup egress PE by the VPN FR. So we also provide two use cases from the operators in this white paper. The first one is from the China Mobile. China Mobile has deployed the SRv6 in the cloud private network and makes the E2E service deployment simple. And it covered 31 provinces across the whole country, and with a bandwidth of the 47 terabits per second. And China Mobile used the single AS and the single layer SD controller to distribute the SRv6 CC policy. And it will achieve date level service opening and the second level bandwidth adjustment. And in this CPN, China Mobile has deployed many new services, including the new VPN dedicated line, cloud computer service, and the cloud mobile phone. And the second use case from the MTN. MTN uses the CC in the IP run and the backbone network for the end-to-end SRv6 policy. And it uses the L2 and L3 EVPN for the mobile and enterprise services, and use the TRV and the VPNFR protection. And in the network, it will over 20 nodes with the 20 seeds in the seed list. And in the extreme 20 hop scenarios, both for the 3G and 4G services, the carrying efficiency can be improved very much. So at the last, I will show the white paper information, including file paths, including the background, history, and the deployment scenarios and the practice, and the deploy case and the prospect. If you have interest for the white paper, you can scan the QR code to get the full text of this white paper. Thank you.
Any question? Thank you for the presentation. Oh, we have one from Rakesh. Go ahead, Rakesh.
Rakesh Gandhi from Cisco Systems. On slide 7, I think you mentioned stamp for link and services, but not for the SR policy. I was just wondering, was there a reason why not use stamp for SR policy as well?
Which slide?
I think it was 7, I believe.
Visualization?
Yeah, this one. At the link you have it. For service you have it, but not for the policy. What was the
you mean the physical
stamp? You have IOM, IFIT stamp. So for C-seed policy visualization, there is no stamp used there. So I was just wondering, was there a reason for it?
You mean the physical topology information?
So the stamp as a protocol, the simple two-way active measurement protocol for physical topology visualization is used for the per link latency, which is great. It's also used for the service visualization as well. That's great as well. Just wondering why it's not there for the C-seed policy visualization.
The physical topology is only for the per link, and the C-seed policy visualization for the whole policy parse.
Yeah, I was just wondering if, because you can use the stamp as well to the latency loss measurement as well, even for the policy. So, thanks.
Maybe Rakesh, to make it clear your point, you should write it in the chat and in the list, and then you can take your time to answer.
Okay, thanks.
Thank you. Mike? Help us make some time.
5, 7 minutes.
Okay, sure. So this draft, its purpose is to be able to provide migration guidance, and particularly in a vendor neutral way. You can go to vendors' websites and find some guidance on migrating from an MPLS network to SRv6 network. And we've had customers ask us about, you know, what IETF will provide for this. And so this is the second time we're presenting this draft. And that's the update that I'm going to provide. So we did provide new authors. Turkcell amendment from Turkcell presented last IETF in this working group. We added him and Urson. They provided some great additions to the draft, including a presentation that we gave at China's Network Operators Group. We presented there to get some feedback on, you know, this topic, and we received some pretty good questions like, you know, am I able to take our existing configuration and leverage any of that when we migrate from MPLS to SRv6? And we're like, I think you just got to start from scratch. At least that's what Turkcell's doing. But maybe if you're using NetConf Yang, maybe there's ways that you can leverage some of that configuration and, you know, in the new configuration. We could use your input for that because we have no idea. In this draft, we focused in on 3 primary migration options: overlays, ships in the night, and interworking. We mentioned that last time. We received your feedback that we need to provide some diagrams, which we've done. And this draft is something that we think that it's ready for adoption in its current form, but it's something that it could be quite large, that we really have to try to figure out all the different things we want to put in it. We started off the draft talking about, you know, you can migrate your network in a progressive way or maybe more in a direct way. So if you're currently using IP MPLS, it would be less risky and pretty easy to just continue to use labels and migrate to SR MPLS. Your hardware already supports labels, and so it'd be a pretty easy migration. So we talk about that. Or if you already have IPv6 throughout your network and you're comfortable with it, then you can directly configure, you can directly migrate to SRv6 without using SR MPLS first. So these are the kind of things that we're talking about. Ships in the night, this is a section on that. Please read the draft. I think we're going to continue to use that term. It seems to be a pretty common term. You're just running separate networks, or you know, 2 different control and data planes. They coexist as ships in the night. There are some drawbacks. Migration from one to the other can be performed, and we have a section where we provide like 12 or so steps that will continue to expand on how you go about doing that. This is just one way to kind of visually look at it. So if you have a existing IPv4 network, MPLS network, you're running IGP like ISIS, LDP, you have a route reflector distributing VPN-v4 routes, and you have a VPN, then what you could do then is start configuring IPv6 throughout your network, then a SRv6 range, and introduce a route reflector. I'm still using the same VPN. And then, so right here we have ships in the night, just they're coexisting, they're doing their own thing across the network. They don't know about each other, although they're using the same VPN. And then you can migrate your services from MPLS to SRv6, and then eventually just get rid of MPLS if you want to do that. So those are the things we're talking about in the draft. Another section is on interworking. This is a draft that's in the Spring Working Group, where it talks about the interworking procedures. So it's kind of more about coexistence. You have islands, and you're using something like a segment routing mapping server to stitch the path across the different data planes. And so we get into this in the network, in the draft as well. And then overlay, this could be quite extensive. This is a popular solution as well, where the underlying network provides transport, and the overlay provides the services. We cover various scenarios in this section, whether using native IPv6, 6PE, L3VPN, and L2VPN. And there's, you know, we probably need to include, based upon the one presentation, eVPN and pseudowires and other things as well. So just to kind of visually depicts just one example, and that is using 6 provider edge, where you're using MPLS in the core and providing that encapsulation service for your IPv6 segments of your network and your PEs. So you have SRv6 on the PEs, and you're using 6 PE to encapsulate that in the core. And so that was a quick run through. But so we are requesting adoption. We think it's probably ready to do so. We will update it with Drew's suggestions on the list. Again, there's quite a lot of other things that we can add to this draft. We're trying to keep it pretty straightforward and not provide any justification why you would want to go to SRv6. You may, one of the questions again was on micro-SIDs when we presented this at the Chicago Network Operating Groups. And so, one of the comments was, would there be situations where we may not want to use header compression, and what are some ramifications there? So those are some things that we're considering. And that's it. I don't know if we have time for questions.
Yeah,
or
is
not.
there any questions?
Definitely have time for questions.
Okay.
We have time.
Okay, good.
Any questions? Right, so regarding adoption, I think let's just wait for the update and then we will do it. I think the document is looking good. Thanks for making progress every meeting. But let's not wait for the next meeting. Let's just make an update and we can start doing the adoption for this one as well when the document is in good shape.
So as a general question, there's a good chance that this working group may start adopting drafts between now and the next meeting. Okay, very good.
Hi, good morning. This is Pablo Camarillo from Cisco presenting on behalf of the rest of the co-authors on SRv6 end-to-end data center frontend and one. This is one common deployment that we think it's quite useful to document that this is actually work that we are doing with Alexei at Nebius. And basically today what they had in their network is a fragmented data center on one, meaning that they had a data center network that is running VX1 and a one network where they were running segment routing and PLS. In between, they had this data center interconnect where they were basically doing the protocol translation to go from VXLAN to SRMPLS. In this design, they are experiencing several challenges, mainly related to the data center, to the DCI protocol translation, because of the performance penalty, because not all hardware can do that functionality at line rate. Not all chipsets have the functionality. The functionality is different in between different chipsets. It's a scalability bottleneck, and obviously it has an associated cost. On top of that, on this design, especially on the VXLAN, it's extremely difficult to do the service insertion in a flexible manner. The requirement is to do firewall service insertion, and basically you don't have any means of doing traffic engineering. And so the only way in which they could deploy the security service, the firewall, is by having this firewall near the perimeter, near the edge, and steer all the traffic through it. And basically what this meant is that because the firewall is a stateful firewall, you had to do very large firewall clusters, and then you have scalability issues with this firewall. And last but not least, there is a dependency on having IPv4 loopbacks configured on these devices. So the design now, what it's moved is to do SRv6 end-to-end across the data center front end and the one. The first immediate benefit is that you don't have to do the protocol translation on the DCI. This is obviously already a huge benefit. Then there is a lower MTU tax, meaning the overhead of SRv6, because with SRv6, with CSIT Next, you can already encode 6 instructions into the IPv6 destination address. That's less overhead than what you get with VXLAN. It's an IPv6 end-to-end solution. You remove the IPv4 loopbacks from the network. And then the most interesting part comes with the service insertion, with the security. With the security, what you want to do is to have the flexibility to steer some traffic through firewall appliances for those customers who are paying for this service. With SRv6, it's quite simple because at the end, what you're just going to do is just simply going to assign a microsig to this firewall service. In this case, the firewall service is basically an open source appliance based on DPDK that is just simply going to inspect the inner packet. And so what we are doing is that we are adding an anycast that is going to bring you to this to a specific service leaf, which is a router, and then you're going to use an adjacency to make sure that this packet goes through the firewall. This flexible service insertion, what it's going to mean is that you can have a smaller firewall clusters through the network that are distributed instead of having it one big firewall cluster near the perimeter. And basically these smaller clusters are much more scalable. And then there is one last benefit that is basically that you can do the egress peer engineering. This is a very high-level overview of the draft. In the draft, we explain that, for example, the SRv6 encapsulation on the top of rack, it can be done either on a physical top of rack or basically in a virtualized appliance, which is, for example, the case Nibius. In the draft, we also explain the several considerations for how to do the control plane, how to steer this traffic through the firewall appliance, which is done with a color-only SR policy, which is quite nice. And you have all of the details in the appendix. And that's a bit it high level. So if anyone, well, we are seeking a working group feedback on this document and eventually adoption. If anyone is interested on this work, please feel free to reach us and collaborate on this document. Any question?
Jorge Rabadan, Nokia. Oh, thanks very much for this. I still need to read the draft, so sorry about that. But it called my attention that you had one of the challenges, the IPv4 loopback dependency. Can you explain that? Because if you refer to VXLAN, it could also be V6, right?
Agree that theoretically in VXLAN and in SRMPLS, it could be purely V6, but the reality of most vendors' implementations is that in many vendors, you still require the IPv4 loopbacks.
Okay, but there's no
I agree
technical...
theoretically, but it's a practical consideration from today.
All right, that's...
I agree with you.
Okay, thanks.
Yes. So we're going to the second draft. Are we on time? Okay. Okay. So very, very quickly, the second draft is SRv6 for deterministic path placements in backends. Again, presenting on behalf of my co-authors. In this case, this is work that we've done together with Chris Martin from Oracle and Kieran from IBM Cloud. I think more or less all of you have already heard about the characteristics of the AI workloads, and if not, listen to the recording of yesterday from the IDC site meeting. But basically, the AI training workloads, they are predictable elephant flows. The predictable is extremely important part of it, and they are really bursty traffics. They are filling up all of the link capacity, and they are synchronized. Because of the low entropy, what is happening is that you have hash collisions. So with this pure ECMP network, you're going to have a really bad job completion time, and this is obviously costing a lot of money. And so basically, the work that we are doing here is that we are leveraging SRv6 for deterministic path placement through an AI backend. The way that it works is that you have a fabric where you have SRv6 provisions since day zero. So basically, you just have the microsits instantiated all over the network, either using UNs or UA instructions. So basically, prefixes or adjacency sits. And then before, when an AI job is being orchestrated, before the traffic is sent on the link, what you're going to do is you compute the segment routing policies with paths that is overall making utilization of the network homogeneous. This is configured on the NIC of the devices. How that is configured is a bit implementation specific and depends on the NIC vendor that you are using. But basically, the key benefit is because you have this deterministic path placement ability through the fabric, you can have much better utilization. There are several techniques, but if you were yesterday on the IDC site meeting, one of the key takeaways is that you really need to explore the multipath nature of the fabric. There are several other ways of doing so, like some people, for example, is playing with the entropy value for example, with that you have in the UDP source port to make sure that you use a different ECMP path. For us with SRv6, because you can explicitly select a path in the fabric, you can ensure that you use a deterministic path. Another of the benefits of this solution is that it's completely open standard compared to all of the proprietary solutions that are other in the industry which are proprietary. So it fits quite nicely. And then there is an implementation of this work in Sonic. Microsoft has been presenting publicly on it, so I encourage you to read the draft, but specifically to listen to the recording from Microsoft where they explain clearly how they use it. We are extending this draft. We are adding how to do overlay tenant separation, meaning how to use a shared infrastructure for different AI workloads for different customers, including the VPN separation, and also how to integrate this with a whenever you need to do training across different data centers, because you don't have enough power within one single data center. You want to extend and go across several data centers in the same region, and then you have obviously the traffic engineering needs in the metro. So we are extending the draft with this. Again, encourage you to read the draft, provide feedback, and if anyone is interested, please join us. Thank you. Thanks, Jeff.
Jeff Mansura, NVIDIA. I'm actually building this, but have a comment. There's word easy in the draft. There's nothing easy about this. It's probably easy on the fabric because we remove all of the channelity. It's dumb cross connect. But practically, we have taken 30 years of work in IETF and put it in a number of controllers. There's nothing easy about this. The amount of complexity is staggering. And the fact that you move complexity from fabric into the NIC doesn't make the solution simple, right? It's very valuable, but it's an extremely complex solution. I would really like you to spell this out in the draft. You've moved complexity, but you didn't remove it. It's really, really complex to have 100,000 plus NICs figuring out what entropy to use, which path to use, whether it's active, inactive, monitoring of this. It's staggering amount of work.
I agree that there is basically a lot of intelligence that we are putting into the NIC, obviously. Because in this case, we are starting SRv6 from the NIC, although it could also be started from basically from a smart top of Fractal. It will be one of the things that we will add. But the point is that on the NIC is where you have the congestion feedback loop, and that is the best place where basically you can switch the SRv6 path from one to another. So we feel that that is the right place where you start SRv6. And then obviously, as in any source routing mechanism, you bring the intelligence to the source. So I agree that there is a level of complexity that you need to handle on the source, which in this case is the NIC.
You are talking to 100,000 endpoints. There's not little complexity. There's a huge amount of complexity. And the fact that you are looking on the fabric part it's not the complete thing, right? Just talk about this from end to end, not just the middle part. I think it would be very useful.
Yeah, no, I agree that we are bringing basically all of the intelligences on the NIC. We need to do the path computation. You need to provision also backup path in case that the primary path is experiencing a performance degradation in the fabric. The fabric is relatively simple because at the end, the only thing that you need to do, it's a stateless fabric, and you have a lot of intelligence on the NIC. Whether handling the NICs is something complex or not, well, with all of the automation that we have today, it is not such a big deal, but I agree that we are bringing the complexity there. I agree with you there.
Just spell it out. And it's not a PC world where you compute a path and use it for 3 days. You've got 10 microseconds to recompute the path, right? So
yeah.
Just spell it out.
Okay.
Keyur Patel Arcus, we love this work. This is one of the ways of the fabric that we are looking at as well at Arcus. I agree with you that the complexity will move to the next. I agree with you that the steering can be done from the source routing standpoint. I agree that if you look at source routing, it provides benefit to and provides an alternative to entropy-based hashing that you could otherwise do. So we'd love to collaborate on that, and we'd love to call out the scale as well as performance enhancements that can be done. Last but not the least, this also holds a promise through SRv6 to provide a hybrid fabrics in future, which is not the case today. Yeah, thank you. Good work.
I agree. Thank you, and let's chat afterwards.
Thank you so much. And our apologies to the last presenter. That presentation was actually from six-man draft. It was for information. Unfortunately, we don't have time to present that. But please use our mailing list. You can send the information from the presenters, share your slides, share what feedback explicitly you need from SRv6Ops, and I hope we can conclude that work on the mailing list. Thank you, everyone.
The terrace coming here.